All right, some of us still have graphing issues. And this is, these are the last functions that we're going to be learning this year. So next year, these graphs need to be left down. And some of you guys are still not showing, you see, if you show me that you know the base graph, I can give you points, but some of you don't show that. So, yeah. So, y equals sine inverse, and how many times do I have to give you this one, right? So, if you just show me the base graph, I give you 1 point, I believe. I think I did. Okay, so remember the range, and here's -1 and 1. So sine inverse looks like this, yeah? At this point, I don't care already if you just memorizing or like the way I told you I do it, figure it out, right? Okay, now what do you have to do to this graph? Well, if you think about it this way, you have to shift it 2 to the left first, and then you reflect it over the y. So if this graph gets reflected 2 to the left, and this point goes here, this point goes here, I guess I need one more there, and then this point goes here. So the graph looks like this. And then now you reflect it over the y, so we're going to need more. Got to go all the way up to 3. So this point comes here, this point goes there, this point goes there, so the graph looks like this. And some of you, I'm not sure what you guys are doing. These are the endpoints of the graph. Some of you have arrows, and there are no. It doesn't go on forever. It just stops. Sine inverse stops here, and it stops there. Okay, number B. Y equal 2 cosine inverse x minus pi. So draw this graph, multiply the y coordinates by 2, and then subtract pi, so shift it down pi. So cosine inverse, okay, so the range is from 0 to pi, right? Yeah, let's just do that, 1 and -1. So cosine inverse looks like this. And these are endpoints now, it doesn't go on, some of you have asymptotes, there's no asymptotes on these graphs. Okay, multiply the y coordinates by 2, so poof, that's the easiest thing to do there. And then shift everything down pi. So each one of these is pi. So shift it down pi. So this point comes here, this point goes there, this point goes there, and then there you go, something like that. C. Okay, so the base graph is this. Then you shift it down pi over 2, and absolute value on the whole thing means everything below the x-axis gets reflected above, right? So first you got to start with the base graph. So -pi over 2 to pi over 2. Now this one has asymptotes. This is tan inverse right there. This graph, probably out of the 6, this one comes up the most in BC calculus right there. Shift everything down pi over 2, so everything goes down, even the asymptotes. So the asymptotes are here and here now, so the graph looks like this. And then now you take this graph and reflect it over the x-axis. So that means, see, everything is below, so the whole thing gets reflected above, which means the 2 asymptotes are like this. So the graph is going to look like this now. Hey, Mr. Park, it looks like the cotan inverse graph. In fact, it is. It is the cotan inverse graph. And then D, Y, you only have to do one thing to this one. Draw this graph first. When you put the absolute value only on the x, erase everything to the left of the y-axis, keep it reflect above the y, right? So, the range goes from -pi over 2 to pi over 2. Right? And then remember, if you forgot how to graph, sine inverse looks like this. So cosecant inverse, you're going to have to hump left and hump right. That's what the graph looks like. So let's erase this because this part is not. Okay? So erase everything to the left of the y-axis. Keep and reflect the remaining portion about the y. So this looks like that. Number 2A. Okay, Okay, some of you are not remembering your range. That's a fatal error in this problem. So cotangent of what angle is negative root 3, but your answer has to be in the range. So that's why the answer is 5 pi over 6, because some of you had negative pi over 6, but that's not in the range for cotangent inverse. Yeah. B, arc cosecant negative 2 means cosecant of what angle is negative 2. And again, if you don't like cosecant, change it to sine. Sine of what angle is negative half. Maybe what some of you did up here, maybe you just said, oh, I don't like cotangent, so you changed it, you take the reciprocal of both sides. Yeah, you can do that, but you gotta keep the same range though. You cannot change the range, right? So sine of what angle is negative half? And your answer gotta be in the range. Negative pi over 6 is the answer. And then C, what do we got here? Some of you are drawing the triangle in the wrong quadrant, and that's why we're getting a fatal error for that one. So tan inverse. The range goes from negative pi over 2 to pi over 2. So if it's negative, you got to draw it in the fourth quadrant. It's over here. So tan inverse is opposite over adjacent, and this would be radical 13, right? So what is the sine of this angle? Opposite over hypotenuse, so that is a negative 2 over root 13. Okay, next page, no, not yet. D, cosine, I think this was one of the better problems right here. Tan inverse I 4/3 plus cotan inverse 5/12. Okay, so if you draw the triangle for both of these, opposite over adjacent, and then this one over here is going to be adjacent over opposite. So why don't we call this one alpha and that one beta? So cosine of the first, cosine of the second, minus sine of the first, sine of the second. This is your identity. And then just look at those triangles. Cosine of this, adjacent over hypotenuse. Cosine of that, adjacent over hypotenuse. Sine of this, opposite over hypotenuse, and then opposite over hypotenuse. So what is that? 15 minus 48 over 65. Final answer, negative 33 over 65. Okay, now second page. E. Oh! Cosine of 2 theta. Arc cosecant 4/3. This is an angle. So cosine 2 theta, you can use whatever, there's 3 identities. Some people, like if you got the wrong identity, I don't. Cosine squared minus sine squared is my favorite. And then all you gotta do is draw the triangle. So cosecant is this over that, so using the Pythagorean theorem, wouldn't that be root 7? Okay, so if you look at the picture, cosine is adjacent over hypotenuse squared, and then opposite over hypotenuse squared. 7/16 minus 9/16 is negative 2/16, which is negative 1/8. So the most common errors of this one, wrong identity, or it didn't draw the triangle correctly. F. I keep giving, I think this appeared in the last two tests, the test problem. Okay, think of that as an angle. So you're going to have to use a half angle, right? Sine of 1/2 theta, plus or minus this. Wait a minute. Sorry, we're videoing. We can't go to this side of the board. Ooh. That means we got to do the problem again. Okay, just pretend you didn't see this. E, cosine of 2 theta. Arc cosecant 4/3. So cosine, why don't we use a different identity then? No, this is still my favorite. I'm still doing it. So if you draw the triangle 4/3 root 7. So cosine is adjacent over hypotenuse squared, opposite over hypotenuse squared. 7/16 minus 9/16, negative 2/16, negative 1/8. All right, F. Let's squeeze it in here. sine of 1/2 arc tangent 24/7. So, when you draw the triangle, tangent is opposite over adjacent and then Pythagorean theorem. So, plus or minus the square root of 1 minus cosine theta over 2. Some of you are getting wrong identity. So first you got to figure out which one to use. Well, if this angle is in the first quadrant, because that's positive, when you half it, isn't it still in the first quadrant? So it's going to be plus, right? Everything in the first quadrant is positive. So, and then now you just look at the triangle. Cosine is adjacent over hypotenuse. I can't believe the number of people that got this, but couldn't simplify it to get the answer. This is pre-algebra right here. Anyway, what would I do? I would multiply top and bottom, well, inside the radical, multiply top and bottom by 25. So 25 minus 7 over 50. Because some of you guys are getting answers that are like bigger than 1. That's impossible. When you take the sine or cosine of something, it's always going to be between -1 and 1. Right? If you get something bigger than 1, you did something wrong. So this is the square root of 18 over 50, which reduces to 9 over 25, and both of those numbers can be square rooted. 3/5 is your answer. Yeah, I gave that. I love giving that. So, but it doesn't matter if you don't remember. I mean, you got to be able to simplify here. Okay, solving equations. Do you guys recognize this? Like we did it as an example in class, plus it was in the examples. I had another one ready, but then this one was a lot easier. So most people sine both sides, which is perfectly good. So if you sine both sides, then this side is x. That's good. Now over here, you got to use double angle identity, sine of 2 theta, right? So, we draw the triangle. I'll draw it over here. Cosine inverse x means adjacent over hypotenuse has to be x. And then you use the Pythagorean theorem. So sine of 2 theta is 2 sine theta cosine theta. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Okay, so if you got that, you got 1 point. But then now you got to do the rest. So what do you want to do? Square both sides now or later to get rid of the radical? Do not cancel the x from both sides. I keep telling you guys that. Do not cancel the variable from both sides. Make one side 0. Factor it out. If something times something equals 0, that means either this one is 0 or this one is 0. So that means 2 root 1 minus x squared equal 1. So this one is already solved, so you just got to go with this one. Before I square both sides, I'm going to divide by 2. Now square both sides. So x squared equals 3/4. X equals plus or minus. Some of you are still not putting plus or minus when you square root both sides. That's big, you know. So there are 3 answers to this problem. I'll write them all. And then some of you didn't check. Anytime you solve any inverse trig equation, you have to check. You just have to. Okay, if you plug 0 into this original equation, you're gonna get, it's like I did it already, yeah? 2 times cosine inverse 0 is pi over 2. Is that equal to sine inverse 0, which is 0? Is pi equal to 0? No, so you cross it out. Now plug in root 3 over 2. Cosine inverse root 3 over 2 is pi over 6. Sine inverse root 3 over 2 is pi over 3. Is that true? Yeah, so that's good. If you plug in negative root 3 over 2, you get 2 times cosine inverse negative root 3 over 2 is 5 pi over 6. Is that equal to sine inverse negative root 3 over 2, which is negative pi over 3? No, so those have to be crossed out. Okay, B. Okay, here's your original equation. Okay, most people tangented both sides. In fact, I think everybody did. Nobody took the challenge. Cosine or sine both sides. Arc tangent 5 over 2. Okay, so you got tan x equals, okay, now, tangent of gorilla plus banana, you gotta apply the identity. Tangent of the first plus tangent of the second, all over 1 minus tangent of the first times tangent of the second. And then, come on, we gotta be able to simplify. If you cannot simplify this, then there's no, pretty much you can't get the answer already. Multiply top and bottom by 6, that's the least common denominator. So multiply this by 6, you get 14. Multiply this by 6, you get 15. Multiply that by 6, you get 6. Multiply this by 6, you get 35. So you get 29 over negative 29, which is negative 1. Because if you don't get, okay, look, if you don't get negative 1 or negative root 3 or root 3 over 3 or 0, cannot do the problem. Okay, so now tangent of what angle is negative 1? Some of you are still putting the wrong one. Because how can you add two positive angles up and get a negative? Cannot. So that's why I told you guys, draw the picture. How do you draw an angle that's arctan 7/3? You just make sure opposite over adjacent, maybe a little bit, yeah, something like that. Opposite over adjacent is 7 over 3. You know, just eyeball it. You don't have to make it exact. See, because look, if this is 3, you go 3, 6, and then, oh, a little bit too big, but that's okay. What about arctangent 5/2? So, you make opposite over adjacent 5:2 ratio. Let's get this one right then. 2, yeah, that's about right. Okay, but what we want to do is we want to stack it. So take this and stack it on top of this one. So if this is 2, then you go 2, 4, 5, a little bit. So what happens when you add those two angles up? What does that look like? Well, it's certainly not negative, right? What does it look like? 3 pi over 4, that's right. And that's your answer. Okay, last page. Number 4, 8 cosine. Okay, some people now. How many people did this? About 5 people? It says write it as a sine function. 5 people did cosine. Oh, I don't know what I can do. Okay, what is the magic number? It's the square root of this squared plus this squared, that's 17. There's a whole bunch of people that, come on, 8, 15, 17. It's a Pythagorean triple. So factor out the 17, and you get this. Okay, now, if you're going to write this as a sine function, then you got to change this to sine. Because the identity is sine, cosine, cosine, sine, right? So now you got to ask yourself, cosine of what angle will give me 8 over 17? What am I doing? Sine. I just said sine too. Sine of what angle will give you this? Most people just wrote sine inverse 8/17, right? Because sine of sine inverse gorilla is just gorilla, right? Or you could draw the triangle. I'll draw it up here. So sine of what angle is 8/17? Well, this angle right there. So you can call it sine inverse 8/17. Some people did tan inverse 8/15. I don't care. It doesn't matter because there's 6 ways to label an angle there. Cosine x minus, now, the cosine of what angle will give me 15/17? Well, that same angle there. So whatever you called it here, just put it here. And then sine x. And then you go, hey, you somebody. This is the identity for sine of gorilla minus banana. So gorilla minus banana. And then I told you guys, you cannot leave your answer like this. So since sine is an odd function, can I just put the x in the front like this? No. Because sine of negative theta is equal to negative sine theta. So this is your final answer. I think I only took off 1 if you didn't do this, but actually it should be 2, but whatever. And then 5. This is like the 3rd time we had this problem. And I'm on the homework, I don't know how many times we had it. If f of x is, I gave you the easy one too. Some of you are you guys just tried to memorize the homework problem, and that didn't work out well. I gave you the easy one. So what would happen if you take g of x and plug it into f of x? You get secant of secant inverse x, which we know is x. So how do you graph y equal x? Isn't it like this? Yeah, but again, for the 3rd time, you gotta look at the domain of the inner function. This is the inner function. What is the domain of that? Okay, well, let's look at, oh, do I really want to draw the graph again? Okay, I will. Okay, so here's 1, -1. So cosine inverse looks like this. Therefore, secant inverse is going to look like this. Hump left and hump right. What is the domain? From negative infinity to -1, and then from 1 to infinity, right? That's where the graph is, right? A listing of all the x coordinates. So, do I graph the entire line y equal x? No, because you got to look at the domain of the inner function. Because you cannot even plug in numbers between -1 and 1. So the graph should look like this. Like the one I gave you on the homework. Wasn't the domain between -1 and 1, so it was only this part of it? There was a homework problem with this? Oh boy. And then the last, okay, you know what? If I'm going to tell you what problem's on the quiz, you guys got to nail it. Oh, yeah. So I'm telling you all 8 problems on Friday's quiz. Okay? It's up to you. Are you willing to, do you have the ganas to do the problems? What is ganas again? Who takes Spanish here? Okay, what is ganas?
Desire.
Thank you. Desire. Now I gotta reach down. I got it. Okay, so the poster problem. Come on. Probably we didn't study it enough. So 3.5, 1.25 theta. How far from the wall should you stand? So, would you agree that this angle here is simply this big angle minus the small angle? So this big angle is tan inverse opposite over adjacent. So what is that? 4.75 over x. Minus this angle. Now what is this angle? Tan inverse opposite over adjacent. Except it's 1.25. Punch this. In fact, from your homework, didn't you already have this on your calculator already? Just change the numbers, man. Anyway, make sure your calculator's in radian mode, and you should see this. I think the graph looked like this. There was a maximum point. What are the coordinates of this maximum point? 2.437, comma 0.623. Okay, so what's the answer? How far from the wall should you stand? Is the answer 2.437 or is it 0.623? Come on, this is x and this is y. This is x, this is y. So the answer is 2.437. All right, so if you guys looked at my email, there's 8 problems on Friday's quiz. I'm going to let you use the whole period. Because the homework for that day, if you looked at the assignment sheet, is catch up or get ahead. Yeah, right, get ahead. So catch up. But then why would you catch up? The quiz is on Friday, right? So I guess the strategy is to get ahead. Or just fall asleep then, whatever. Okay, so the first problem, that's the only problem that doesn't involve a calculator. All the other 7 problems you need a calculator. Mr. Park, there were some problems on the homework that didn't involve a calculator? Yes. Yes, in fact, on last night's homework, where's the median problem? Number 5. Okay, the problem is going to be like that one, but I listed it under tritrig 3 because there was another one that was just like it. And you know what? Since we have the time, I'm going to actually do that. This is number 1 on Friday's quiz. See, I don't know what you guys think. You know what would make me the happiest teacher in the world? If everybody got perfect on the quiz. I'm not trying to make problems to trick you, you know. I don't know if that's what you guys think. My life would be a lot simpler if everybody got perfect. Okay, so I'm going to do this problem, again, like I said, number 5. And it's on the video, but I'm going to do it anyway, because I don't know if you guys even look at my videos or not. Okay, given triangle ABC, I don't even know if this is drawn to scale. A is 8, B is 4, so definitely not drawn to scale. C is 6. Find the length of the median from A. So here's A. The median goes from here to the midpoint of the opposite side. So that means 4 and 4, correct? Okay, so there's another problem just like this on tritrig 3, except it's not the median, so it's like different numbers, but you're going to use the same technique. This is called the mama bear, baby bear technique. See, look there. Use the law of cosines on the baby bear and then on the mama bear. Okay, so what are we trying to find? The length of the median. So this is what we're trying to find. So either you're going to use, see, this side belongs to this triangle or this triangle. So you can use either angle B or C. It doesn't matter. Which one you guys want to use? Which one did I use on the video? Tanaka? Because I know you watched the video. Okay, so probably I use B because B stands for banana. Let's do C then. Let's do something different. Let's call this theta. So all you have to do, use the law of cosines on the mama bear, that's the big triangle, and then use the law of cosines on the baby bear. See how the baby bear is in the womb of the mama bear? What's a womb? Okay, big triangle. Look at the big triangle. If this is the angle, then how does law of cosine start? Should I go 6 squared, 4 squared, or 8 squared? 6. It's opposite the angle. So 6 squared equals 4 squared plus 8 squared minus 2, 4, 8. Right? Whatever these two sides are, bam, you put it there. Cosine theta. Now use the law of cosines on the baby bear. Just this one right here. Okay? So how do I start it? X squared. See, because it's opposite the angle. X squared is equal to 4 squared plus 4 squared minus 2, 4, 4. And again, see how these two sides are? Cosine theta. So can't you solve for cosine theta in this equation? And then plug it in here, pow. No need calculator. So in this first equation, you just got a number crunch. Can we do that? I don't know. 36 is equal to 16 plus 64 minus, what is 8 times 8?
64.
Cosine theta. So 64 cosine theta is equal to 80 minus 36. Huh? 80 minus 36.
0.4.
What? Is that right? Oh yeah, it is right, yeah. 80 minus 36. Okay, so therefore cosine theta equal 44 over 64. And I'm going to tell you, to make your life easier, you want to reduce this fraction. I can reduce by
11, 16.
4.
Yeah.
So 11 over 16. Okay, take this number, plug it in here, and then now you can solve for x, right? So, where am I going? X squared is equal to 16 plus 16 minus 32, right? This is 32 times cosine theta. But cosine theta is 11 over 16. 16 goes into 32 twice. So you got 32 minus 22, which is 10. X is root 10. Can you repeat this? Well, there's one of two problems on the quiz, right? On number one. What was the other one I told you? It's on tonight's homework. But you're gonna use the law of cosines on the baby bear and mama bear again. Okay, so just make sure if you can do those problems, there's no reason why you can't get a perfect on the quiz. Plus you gotta get I'm gonna give you the whole period, even though it should only take like 30-something minutes. So are there any other problems on last night's homework? And again, I'm gonna warn you now, number 8, last year, that was the only problem I looked at the whole year. Because I told you the probability of me even looking at your homework is very small, but I'm gonna tell you right now, number 8, last year, some people they didn't believe me or something, so they didn't, I started the problem for them, they didn't even finish it, so they got 0 out of 25 on the homework. You know how that affects your grade? Very badly. But then you guys, I have the solutions in there, so at least you can copy it down, right? Don't copy! You don't learn anything from copying. Well, you learn how to copy. Anyway, did you guys ever notice that in any triangle, this is a really neat theorem. That's why I gave it to you. In any triangle, can be 30, 60, 90, can be 60, 60, 60, can be 40, 20, 120. Any triangle, the tangent of A times tangent B times tangent C is equal to tangent A plus tangent B plus tangent C. Don't you find that fascinating? Apparently not. Anyway, look, do you guys ever think about this? What if it weren't equilateral? What if it was an equilateral triangle, 60, 60, 60? What's the tangent of 60 degrees? Well, that's why we have problems, don't we? It's root 3. Did you guys ever notice that root 3 times root 3 times root 3 is equal to root 3 plus root 3 plus root 3? In other words, that's 3, right? 3 root 3 equals 3 root 3. But it doesn't just work for 60, it works for any triangle. I think that's really amazing. That problem will not be on the quiz though, but like I said, you're just playing with fire if you don't make sure there are problems on your homework. Because I'm not sure even what you guys do. Because normally, I would check homework and then some of you build up a reputation, homework reputation. Or maybe you didn't build it up, but maybe, I don't know what. But see, you guys don't have a reputation because I haven't looked at any so far. So maybe if I look at this, at least you have somewhat of a reputation. Okay, here's tonight's homework. Okay, you know what? I'm going to start you on one of them. Okay, look at where's the one? Right here, number 6. Find the radius of the circle that circumscribes a triangle with sides of length 5, 6, and 7. Do not use a calculator, and if you are befuddled, look at the example. There's an example that shows you exactly how to do this. But you know what? I'm going to tell you right now, and it's going to be on video. So it's either this one or that one right there. That's going to be number 1. That's the only one you cannot use a calculator. So actually, I don't know what you guys do to study. You guys just look at my solution and you go like that, oh yeah, I can do that on the quiz, and then you end up fatal error, right? That's what happens. You got to actually do it by yourself. Okay, now in the example, I think I did 4, 5, and 6. I changed it to 5, 6, and 7. What happens on the quiz if I make it 6, 7, and 8? Well, hopefully you can do it. So find the radius of the circle. So here's the center of the circle. So what you need to do is draw 2 radii. So you can pick any 2. You want to do A, B, or C. It doesn't matter. Okay, you want to do B. I think in the example I did the longest one. So here are your 2 radii. And then all you got to do is do the mama bear, baby bear thing. So both of the problems is the baby bear, mama bear concept. See how this baby bear is in the womb of the mama bear? Okay, now, but this one has a little trig you gotta know, or geometry. If this angle is theta, what is this angle here? It's 2 theta. How come? Okay, let's go back to geometry. What do we call it? Okay, here's the center of the circle. What do we call an angle where the vertex is at the center? We call that a central angle. If this is 50 degrees, then what is this? What is the arc? 50 degrees. Central angle is equal to the arc. Not the length, but the degree measure of the arc. What do you call an angle where the vertex is on the triangle? This is called an inscribed angle. If this is, I don't know, 70 degrees, then what is this angle here? 35. Inscribed angle is always half of the intercepted arc. So if this is 2 theta, doesn't that mean this arc is 2 theta as well? And therefore this angle got to be half of that. Now look, if you wanted to label it theta and theta over 2, you could. But I would think more people would rather use double angle than half angle, right? Because half angle, yeah. So it's up to you. I think double angle. So when you use the baby bear, so use the law of cosines on the baby bear and do it on the mama bear, and then you just have 2 equations just like this to solve. Except this one, you gotta know double angle identity. So I just wanted to set it up for you. Either one of these is going to be number 1 on the quiz. Okay, what time is it? All right, tomorrow, are we starting the next chapter? I think we are. There's only one more chapter left in this for the whole PCH first semester. Okay, let's play a short game and then we can go home, unless you have class. Okay, who won the last game?
Boys.
Boys? Because boys always win? All right, so girls go first. Since we're getting close to Christmas, I have a few Christmas games here. Do you guys get into the Christmas spirit? Okay. So girls go first, girls against boys. Okay, remember we did rebus puzzles? I think it was online when you first started school. Okay, but now it's Christmas carols. So, starting with girls, I'll give you 15 seconds to name. Any girl can, but you can only have 1 answer per person now, per picture. You guys remember what a rebus puzzle is? It's a picture, and then you gotta guess what the Christmas carol is. Okay, girls said Jingle Bells, correct. Boys' turn.
Walking in a winter wonderland.
Yep. Walking in a winter wonderland. Girls?
From Santa Claus.
Close.
Santa Claus is coming to town.
Santa Claus is coming to town. See, because there's a town there. Boys?
Oh, Boston Joy.
You're just reading what it says. Any boy, come on, any boy. You got 1 guess per person. Oh boy. Girls can steal.
Joy to the world.
Joy to the world. See, because look, it says to world.
I can't read.
What? Okay, girls. Okay, I heard Rudolph. I think the red-nosed reindeer, but I'm not sure. Boys. Okay, I'll give you a hint. You see the sign there? That's important. Doesn't show you the whole thing either. Really? Okay, girls can steal. Okay, that sign should say Yellowstone National Park. Guys, have you guys ever been there? What's the biggest tourist attraction there?
Is it something faithful?
Yeah, Old Faithful. Oh, come all ye faithful. Okay, girls.
I'm dreaming of a white Christmas.
Yes, I'm dreaming of a white Christmas. See how Christmas is white? Boys,
Oh, Christmas tree.
yes. I played this in my period 8 class. You know what they said? It's a Christmas tree made of O's. It's not even a song. Old Christmas tree. Girls,
Oh, what child is this?
what was that?
Oh, what child is this?
Yes. What child is this? Get it? Because there's no name. What child is this? Number 10. Boys, we three kings. My period 8 class didn't even know that we meant small. We, W-E-E. This class also. Number 11. Girls,
Deck the hall.
deck the hall. There you go. 12. Boys.
I saw 3 ships.
Yep, I saw 3 ships. Hey. Okay, so that's the halfway mark. The last 12 is anybody can answer. First person to get it. Go.
Silent night.
Holy
Holy
night.
Okay, you know what? I heard there's a tie, so since it's a tie, the losing team gets it. The losing.
I guess so.
You get it? Oh, holy night. Because he has holes in him.
Noel.
First Noel.
The first Noel.
Wow.
Yep. Oh, the boys are making a comeback. It's tied. 7-7 now.
Who is it?
You get it? A weigh in the manger. You're weighing the animal. 16.
12 days of Christmas?
Yes, 12 days of Christmas. See how there's 12 December 25th? 17?
I saw mommy kissing Santa.
Okay, that's a tie, so the boys get it. It's 8-8. Number 18. This is, I think, the hardest one of the whole thing. Okay, I'll give you a hint. That tool on the top is not a pick. Because period 8, they kept saying pick. No, it's not a pick. What's a tool that looks like a pick? It's the part I don't even know what a pick is.
Screwdriver.
It's a tool that looks like a pick that starts with an A.
A nail.
Whose second letter is W.
Oh.
Okay, that's all I can tell you. And it has 3 letters in it.
Oh.
What?
No, 8L, 8L.
Oh.
Huh? Okay, we don't know our tools, so I don't think we're gonna get this.
Oh.
All I want for Christmas is my 2 front teeth.
Huh?
Because that's an all, A-W-L, all. And then wishbone, do you like your wishing or you wanting, right? All I want. And then you see the saw has teeth on it, right? But then it's missing 2 of them. Why am I explaining this? Okay, 19.
Chestnuts roasting and
Okay, girls got that one. 20. No, Christmas carols. It's Christmas carols. Oh, gosh. Somebody take the ball and finish it.
What did you say?
I'm not gonna say.
Midnight green.
No, it came upon a midnight clear. It came upon a midnight clear. You- Okay, I'll take that, boys. So it is 9 to 9. It's actually, let it snow, let it snow, let it snow. Okay, there's only 3 more left.
Silent night.
Tie, so we'll leave it a tie.
A little town of Bethlehem.
Okay, girls got that. Okay, boys, you need this one to tie.
A palm tree.
Here's the last one.
Bethlehem. Yankee Doodle.
Christmas carols. Maybe you guys are too young. Well, back in the old days, they used to have, you heard of the Lone Ranger? Okay. He rode a horse named,
Rudolph.
no. That's why he always used to say, hi-ho, and then the name of his horse.
Cheerio. Friday.
Hi-ho! I can't say it because that gives it away. Okay, look at what the horse is wearing then. Look at this right here. Look at this. Maybe that's a hint you can get it.
Bell. I hope double.
Bell.
Let the bells chime.
Silver bells. Hi-ho, silver! Okay, here, since I got YouTube up, let's just search it. Hi-ho, silver. Am I searching? Am I searching? Or am I just searching my thing, my videos? Who knows how YouTube works? Never mind, just go to regular YouTube and type in hi-ho, silver. The Lone Ranger, there you go. Alrighty then. You guys don't watch old, what's that channel that has the old shows on it? I don't know, but we don't watch it. Alright, tomorrow we start the next chapter.
Mr. Park, I think it's still recording.
Oh no. That means, well, who's gonna even watch the game part, right? We're still recording. Okay, bye.